Our research explores augmenting a digital pen with a miniature projector. This combination produces a small display on the drawing surface, which moves with the pen. This provides the user with rich visual feedback, which is typically absent when using traditional digital pens. Our system consists of an Anoto pattern-based digital pen mounted with a 3D tracking device, which gives the digital pen spatial awareness. The virtual imagery is produced by an overhead projector, simulating a miniature projector mounted on the pen. A button is used for menu activation. We explored this unique design space in the paper-intensive practices used in the architectural domain. Our developed application, PenLight, allows the user to query and augment physical printouts. The functionality which our application possesses is accessed through a virtual menu system. This is in contrast to traditional digital pens, which use pre-printed user interface elements. In PenLight, to access a hierarchical radial menu, the user clicks a button on the pen. We explored 3 techniques for selecting items from the menu. With the first, the user marks on physical paper. With the second, the user holds the button to lock the menu and then gestures in the appropriate direction. With the third, the menu position relative to the physical space is locked, and the user crosses the menu boundaries while in mid-air. We also explored multi-scaled menus. Here, as the pen is moved away from the paper, a more detailed menu of sub-items from the menu hierarchy is displayed. The first technique we demonstrate is augmenting a physical blueprint with a virtual overlay. In this example, the user extracts different layers of information from the pen. Here we have the pipeline layer. Here we show the heating layer. Another technique is measurement. By drawing a line, a path, or an area that the user wants to measure, the physical blueprint will be augmented with the computational result. Search is our third interaction technique. Search can be executed by either circling the item to be searched or by selecting the item listed power outlet in the menu directory. The search result is dynamically generated and displayed. Notice the halo technique is used to indicate power outlets outside the display of the pen. The pen location can be used as a camera angle to create a 3D view of the building plans. As the resulting image does not naturally align with the blueprint, it can be projected anywhere. The pen trail can be used to define a 3D walkthrough and generate a video. Notice the red dot that shows the location of the camera relative to the blueprint as the video is being played. By tracing over lines, strokes can be copied. The copied strokes can then be redrawn with the help of the display overlay to a different sheet of paper to perform a copy and paste operation. Ink being created by another remote user can be pulled from the virtual layer to be overlaid on top of the blueprint. We believe that lessons learned from PenLight can be applied to other application areas in the future.